Alright, so I want to talk a little bit about order of operations, and then I want to introduce something that is probably new for a lot of you, which is called summation notation. The order of operations part will probably just be a little bit of a review, and mostly I just want to make sure that we all know how to use our calculators correctly. So pull up a calculator, whatever calculator you plan on using for this course, so that you can kind of follow along. So let's get to it. So take a moment, maybe pause the video, and see if you can figure out which of these two statements is correct. We're starting out with 12 minus 3 times 2, in both cases, 12 minus 3 times 2, but we're ending up with different answers. We end up with a 6 here and an 18 there. So go ahead and pause the video and see if you can figure out which one is correct. Okay, I'm going to go ahead and try to refocus this first of all, but I'm going to go ahead and state the answer now. So if you don't have an answer yet, pause the video, try to figure it out. But here's the correct answer. So using order of operations, we should do the multiplication first. So we need to do the 3 times 2, which becomes a 6, and then we can do 12 minus 6, which becomes 6. So this first solution is correct. The second solution, it looks like what we did is we did the subtraction first. 12 minus 3 is 9, and then 9 times 2 is 18. But that's wrong, because we're supposed to do the multiplication first. So this one is not correct. So we do multiplication and division before addition and subtraction. If we wanted to do the subtraction first here, then what we would need to do is put parentheses around that subtraction. So 12 minus 3 times 2 written this way is 6, because we would have to do the multiplication first. But if we want to do this subtraction first, we can. We just have to put parentheses around it like this. Okay, so now both of these statements are true statements. Okay, we call this convention order of operations, and you may have learned it as PEMDAS, or please excuse my dear Aunt Sally, or something like that. But in this acronym, P stands for parentheses, and any other grouping symbols like brackets or whatever, and you always work those from the inside out, so the innermost set of parentheses and then outwards. So that's the very first thing you should do when you're trying to work out the answer to an expression. Do the stuff inside of the parentheses first. The next thing you do is exponents. So if there are any exponents, and by the way, this includes square roots, so any exponents or square roots, you do that second. Okay. After that, you do the multiplication and division, and those two things are actually done in the same step. You just work them out from left to right. A lot of students think, well, m comes before d, so I have to do all the multiplication first, but that's not true. You do multiplication and division in the same step in the order that they're written from left to right. And then finally you do addition and subtraction. Once again, same step in the order they're written, working from left to right. So let me give you a few examples, and the answers, if you're looking at your page, the answers are at the bottom here, but let's see if we can arrive at the answers ourselves. Okay, so go ahead and give the video a pause and see if you can come to these answers on your own. Okay, I'm going to go ahead and work out the solution now myself. Okay, so looking at this expression, there are no parentheses, so first step is done. There are no exponents, so the second step is done. So then I move on to multiplication and division. In this case, I've got this division problem right here, 6 divided by 3. And 6 divided by 3 is 2, so I'm going to carry this 3 along, and I'm going to change the 6 divided by 3 into a 2, right? So now all of the multiplication and division is done. I can do the addition, and so you should get 5, right? Just like the answer down here says you should. Part B. This time I do have some parentheses. In fact, I have two sets of parentheses. I have some brackets here and then some parentheses here. So when you have that scenario, you always work from the inside out. So excuse me. So I'm going to do this innermost set of parentheses first. So this is going to be 3 plus 2 times 7 times 3 plus 4 is 7 minus 5. Okay? So the only thing that changed was this 3 plus 4, which I changed into a 7. Everything else stays the same. Okay? Now, here I have parentheses, but notice that there's nothing to do inside of the parentheses. It's just a number. It's just 7. And when you have another number written outside of it, then the operation that's assumed there is multiplication. So this is a multiplication problem now. So I'm working inside of this bigger set of parentheses, these brackets. And inside of there, I have to do 7 times 7 minus 5. And order of operations says that I should do this multiplication before I do the subtraction. So I'm going to do 7 times 7 first. 7 times 7 is 49. Everything else stays the same. Now the next thing I need to do is I need to do the subtraction so that I'm finished doing all of the operations inside of this set of parentheses. So 49 minus 5 is 44. So you can see I'm kind of whittling away at the problem, right? At this point, I have a 3 plus 2 times 44. So I've got to do this multiplication first. 2 times 44 is 88. So this becomes 3 plus 88. And then 3 plus 88 is 91. And that's my final answer, right? Just like this says down here. Okay. Finally, we have part C. Part C says we've got to do 12 divided by 3 times 2 plus 5. Now, I'll repeat again. A lot of times students think PEMDAS, right? M comes before D. So I have to do this multiplication first, and then I have to do the division. But that's not quite right. M and D, multiplication and division, are done in the same step, in the order that they're written, left to right. So we're actually going to do the division first, right? 12 divided by 3 is 4. Everything else stays the same. Then we're going to do the multiplication. And then finally we can do that addition. And we get 13, just like the answer says we should. If you had done the multiplication first, that would have been wrong, and this is what you would have gotten. You would have gotten 12 divided by 6 plus 5. And then you would have said, okay, so now I've got to do the division. 12 divided by 6 is 2. And then 2 plus 5 is 7. But that's the wrong way to do it. Okay? All right. Now here's the deal. I'm not going to actually give you a ton of these kinds of problems to work out by hand. For the most part in statistics we're going to be using our calculator. But the reason that we review order of operations is so that you understand how to use your calculator properly, right? Because sometimes you're going to have to punch stuff into your calculator, and sometimes you need parentheses even where the expression may not have parentheses as it's written on the page. And this is to ensure that your calculator will do things in the correct order. So let me give you an example of this, right? So one of the biggest issues that students have is with expressions like this, 4 plus 10 divided by 3. The way that this is written, there are no parentheses. But when you punch this into your calculator, you need to put parentheses around this stuff in the numerator. Why? Well, because if you just punch in 4 plus 10 divided by 3, just like this, into your calculator, you're going to get about 7.333, and that's the wrong answer. Because as you can see from the way this is written, you should do the 4 plus 10 first. You have to simplify that numerator. You've got to do 4 plus 10 first to get 14, and then divide the 14 by the 3. If you just type it in this way, your calculator is just doing 10 divided by 3, and then it's adding 4. But that's not what you want. You want it to do the 4 plus 10, and then divide that by 3, which means you need parentheses around the 4 plus 10. So the correct way to type it into your calculator is to open up a set of parentheses, put 4 plus 10, close the parentheses, and then divide by 3. And if you do it that way, you should end up with about 4.667. So using your favorite calculator, I'll let you kind of verify that. But I'm going to move on because I have some more examples that I can show you of this. Okay. Before we get to those additional examples, though, let me just say that another mistake that students make involves the square root. Most of the time that they make a mistake, it's because they're trying to punch in something like this, but they end up punching in something like this, or vice versa. Okay, so note the difference here. On this expression, the square root is around the entire expression. For this expression, the square root is only around the numerator. Okay, and they are different things. Okay, so they're different things. All right, so here's how this would work in your calculator. Okay, to do the square root of 5 plus 17 divided by 3, where the whole thing is under the square root, first we would need to simplify 5 plus 17 divided by 3. In order to do that part, you would have to put parentheses. When you're typing it into your calculator, you would have to put parentheses around the numerator, right? And then you want to take the square root, right? So to do this, you have to take the square root of this thing that you've now simplified. So you end up with two sets of parentheses, right? So on your calculator, you first open up your square root, open up a parenthesis, and then type in 5 plus 17 divided by 3. But when you type in the 5 plus 17 divided by 3, the 5 plus 17 needs to be in a separate set of parentheses, right? So you open parenthesis, 5 plus 17, close parenthesis, divide by 3, close parenthesis. And the answer you should get is about 2.780. Okay. With this expression, on the other hand, you just need to simplify 5 plus 17 and then take the square root of it and then divide by 3. So you take the square root of open parentheses 5 plus 17 close parentheses and then divide by 3. So this one is much simpler, but you end up with 1.563 about on that. So with those two things, the fraction problem and the square root problem, now that we've kind of clarified that a little bit, let's run through a few examples. And once again, I have the answers down at the bottom of the page, but go ahead and try these on your own. See if you can get the correct answer. Use your calculator this time. Okay, so don't do it by hand. Use your calculator. Just try to punch the entire expression into the calculator and see if you can get the correct answer. Okay, so I'm going to go ahead and work out this solution now. So I've got this calculator up. I want to do part A, 7 minus 10 divided by 2. In order to do that, I need parentheses around the numerator. So I'm going to open up a set of parentheses, do 7 minus 10, close the parentheses, and then divide by 2. Okay, that's how I want to type it into the calculator. So you should end up with negative 1.5, just like the answers say. If you don't type in the parentheses and you say 7 minus 10 divided by 2, you're going to get the wrong answer. Okay? So you need to have that numerator part in parentheses. Okay, so let's look at part B. Part B was 5.1 plus 9 times 2.3 all over 3 minus 5.5 times 6. So when I punch this into the calculator, I'm going to need parentheses around this stuff in the numerator, and I'm going to need parentheses around this stuff in the denominator. If I leave off the parentheses, then it'll just do 5.1 plus 9 times 2.3 divided by 3 minus 5.5 times 6. And that's not what I want it to do. I want it to do 5.1 plus 9 times 2.3, and then I also want it to do 3 minus 5.5 times 6, and then I want it to divide those two things. So I've got to put parentheses around the stuff in the numerator, parentheses around the stuff in the denominator. Here's what it would look like. So we would open parentheses, do 5.1 plus 9 times 2.3, close the parentheses. That's all of the stuff that was in the numerator. And then I want to divide that by, open up a new set of parentheses for the stuff in the denominator, and you do 3 minus 5.5 times 6. And close that set of parentheses. Okay, this is the correct way to enter it into your calculator. So you should get a negative 0.86, just like the answer key says. Okay, moving on to part C. We want to do 1.8 divided by 3 plus the square root of 5.2. Okay, so let's see what that looks like in the calculator. Well, actually, let me comment on it. So 1.8 is in the numerator. There's no other expression going on here, so there's no other operation that you have to perform. So you don't have to put the 1.8 in parentheses. You can just leave it 1.8. But in the denominator, you do have operations that are happening here, and you need for your calculator to do those operations first before you do this big division. So you're going to need parentheses around the stuff in the denominator. Let's see what it looks like. You would type in 1.8 divided by, open up a set of parentheses, 3 plus square root, and you'll notice that when you use the Google calculator and you type in the square root button, it automatically opens a set of parentheses for you. Sometimes that's a little bit of a nuisance, like in this example, but oftentimes it's useful. In any case, the thing we want to take the square root of is 5.2. So we're going to put 5.2 in there, close the parentheses. That closes the parentheses around the square root stuff. And then we want to close the parentheses around the denominator stuff. So we're going to close parentheses again. This is the correct way to type in part C into your calculator. So you hit enter, and you should get about 0.341, just like the answer key says. You can see that the answer is a little more complicated than that, but it's about 0.341. Now, let me just say, a lot of you have fancy calculators where you just press a little fraction button, and actually, let me show you what I'm talking about. So a lot of you have a fancy little button that looks kind of like this, and you press that button, and then it on your calculator it automatically opens a screen where you can just type stuff into the numerator, type stuff into the denominator. If you have that button, feel free to use it, and then you can avoid all of this confusion about the parentheses and stuff, right? But if you're using the Google calculator or just a basic calculator or whatever, then this is the way that you would type it in. Okay, last one, part D. We have 3 plus 4 times the square root of 5 times 6 divided by 3. So I think I can do this whole thing without using any parentheses at all, except that the Google calculator is going to open up a set of parentheses here, which it should in this case. So actually I will have one set of parentheses. So I need it to do 5 times 6 divided by 3. I don't need to put parentheses around the 5 times 6 in the numerator here, because order of operations says that I'm going to do that multiplication first anyway. So I'm going to do 5 times 6 divided by 3. If it makes you feel better, you can put parentheses around the 5 times 6. That's not going to affect anything, or at least it shouldn't if your calculator is programmed correctly. So let's punch this in. So here's what we should get. We should have 3 plus 4 times square root of 5 times 6 divided by 3. Okay, so you can type it in just like that, and you should end up with about 15.649. Okay, just like the answer key says. Again, if you had put parentheses around the 5 times 6, it wouldn't have changed anything. So again, we could have said 3 plus 4 times square root of, and then I could have put the 5 times 6 in parentheses, and then divided by 3, like that, and you still end up with the same answer. Okay, because it's going to do the 5 times 6 first anyway, so you don't need that extra set of parentheses. Okay, so that's the order of operations. Hopefully that was a good refresher for you, and hopefully you are capable of using your calculator now, using your calculator correctly. So let's talk about sigma notation next. All right. So another symbol that we use a lot in formulas in statistics class is the Greek letter sigma. It's a capital sigma, and it looks like this. You may have seen this on like fraternities and sororities and stuff, but it's a capital sigma. In math, this symbol stands for sum. It means that we need to add up the sequence of numbers that follows that symbol. For example, if you had this symbol here, we read this the sum from I equals 2 to 7 of 2 times I. And so what this means is that we need to add up this expression here, and what the indices here mean, I equals 2 to 7, that means we're going to start at I equals 2, and we're going to continue to increase by 1 until we get to 7. So in other words, this means we're going to start, we're going to plug in 2 for I first, we're going to get 2 times 2. Then we're going to plug in 3 for I, we're going to get 2 times 3. And then we're going to plug in 4 for I, we get 2 times 4. And then 5, and then 6, and then 7. We stop at 7, okay, because that's what this symbol says to do. So it says to start at 2, stop at 7. And then the sigma means you're going to add these expressions up. Okay? Anyway, if you do all that math, order of operations says we've got to do all the multiplications first. So this would be 4 plus 6 plus 8 plus 10 plus 12 plus 14. And then if you punch that into your calculator, you should get 54. Okay? So that's how the sigma notation works. Now, another thing that comes up when we're using the symbol in statistics is that oftentimes we're interested in wanting to add up the values in some data set. And we use subscripts on the letter x in order to represent the different values in our data set. So for example, x1 means the first value in our data set, right? The first datum. x2 means the second datum, right? So the second value in our data set, and so forth. So a quick way to say add up all of the values in the data set is to write sigma I equals 1 to n, right? So the sum from I equals 1 to n of x sub I, where n is the number of values in the data set. All of this is very abstract, and so it may seem kind of overwhelming, but let me give you an example. I think it's easier than it seems at first, right? So let's say that you had this data set, 10, 12, 9, 7, 9, and 11. Okay, so then 10 is the first value in your data set, so that's x1. 12 is the second value in your data set, so that's x2, and so forth, right? So there's x3, x4, x5, and x6. Okay? So if you had an expression that said sum from I equals 1 to 6 of x sub I, that means you're going to replace the I with a 1, and then a 2, and then a 3, and you're going to keep going until you get to 6. So we're going to do x1 plus x2 plus x3 plus x4 plus x5 plus x6. Well, what was x1? It was 10, right? What was x2? Well, it was 12, right? And x3 was 9, and x4 was 7, and x5 was 9, and x6 was 11. So you're just adding up the values of this data set. This is a shorthand way to say add up these values, and you should get 58. Okay, when sums are used in longer calculations, we evaluate the sum first before proceeding with the rest of the order of operations. So let me give you an example of this. Let's say that this is our data set, same data set as before, 10, 12, 9, 7, 9, 11, and let's say that we wanted to calculate this thing, right? So the sum from I equals 6 of xi minus 9.6 divided by 5. So before we do the division, we want to take care of this sum first. So we can start off by replacing the I with a 1, and then a 2, and then a 3, and we're going to keep doing that until we get to 6. So we have x1 minus 9.6 plus x2 minus 9.6 and so forth until we get to x6 minus 9.6. And then we're going to divide that whole thing by 5. Okay, well, so now we can replace the x's with their corresponding values from the data set. x1 should be 10. x2 should be 12. x3 should be 9. x4 should be 7. x5 should be 9. And x6 should be 11. Okay. Now we can take care of all of those subtractions. Feel free to use your calculator, or you could punch the whole thing into your calculator at once, I suppose. But I'm going to take care of these subtractions first. I know that 10 minus 9.6 is 0.4. 12 minus 9.6 should be 2.4. I'm going to start to use my calculator though, so I don't mess myself up. 9 minus 9.6 is negative 0.6. So I'm just going to change this addition to a subtraction since it's a negative 0.6. 7 minus 9.6 is negative 2.6. 9 minus 9.6 I just did a second ago. It's a negative 0.6. And 11 minus 9.6 is 1.4. And I want to divide the whole thing by 5. At this point, you could punch this whole thing into your calculator. Just remember that you need parentheses around the numerator when you're punching it into your calculator. Okay, so if I were doing this using the Google calculator, it would look like this. I would open a set of parentheses and say 0.4 plus 2.4 minus 0.6 minus 2.6 minus 0.6 plus 1.4. Then I would close the parentheses and divide by 5. And you should end up with exactly 0.08. Okay. One last thing, and I've mentioned this before, but I want to mention it again, is that in math, you use an equal sign when the two values are exactly the same. If you've rounded, then it's no longer appropriate to use an equal sign. Instead, we use an approximation sign. Okay? So, for example, it's not true that 3.537 equals 3.5, right? This is not a true statement. But you could say that 3.537 is approximately 3.5. So, try to use the correct symbols. Okay? Try to be rigorous. Okay. So here are some examples. So I've got 4 examples on this page, and then 2 more examples on page 5, and then 1 last example on page 6. But the answers to all of those examples are at the bottom of page 6. So what I would like for you to do is attempt these problems on your own, see if you can get the correct answer, and then check your answers. And if you messed up on anything, then you can continue to watch the video while I work out these answers, okay? So I'm going to go ahead and work them out myself. So here goes. So for number 3, it says, calculate the following, round to 3 decimal places if necessary. We can use a calculator, but we might want to write down some steps, okay? As we show our steps, let's make sure to use the equal sign and the approximation sign appropriately. And this is going to be our data set. Whenever we have xi's, that we need to replace with numbers, with actual numbers, then we'll use that data set. Okay, in part A we don't have any xi's, we just have i's. So if I take turns replacing the I with a 1, and then a 2, and then a 3, and then a 4, and then stop at the 4, here's what I end up with. So this will look like 1 plus 3, plus 2 plus 3, plus 3 plus 3, plus 4 plus 3. Okay, so I'm just replacing the I with a 1, and then a 2, and then a 3, and then a 4. Okay. Now technically I don't have to do the stuff in the parentheses here because it's all just addition, right? So I'm going to do all of this at the same time, really. But just to kind of keep with the steps that we've been doing, I could go ahead and do all of these individual sums. And then I could add those up. Let's see. 9 plus 13 I think should be 22. Let me check. Make sure I got it right. Yep, that's the correct answer. Okay, so that's part A. Now, let's contrast that with part B. On part A, we just had I plus 3. On part B, we have x sub I plus 3. So when I take turns replacing the I with 1, and then 2, and then 3, and then 4, it's going to look like this. x1 plus 3. Not just 1 plus 3, but x sub 1 plus 3. Okay, plus x2 plus 3, plus x3 plus 3, plus x4 plus 3. And now I can replace these x's with their corresponding values from the data set up here, right? So x1 is 7, x2 is 2, x3 is 8, and x4 is 3. And then I can add these things up. We've got 10 plus 6 plus 11 plus 6. Let's see, that's 21 plus 12 more, I think gives us 33. Better double check. Ooh, I got 30. I was supposed to get 32. Is that right? No, I think I'm... Oh, I see my mistake. 2 plus 3 is 5, right? 2 plus 3 is 5. So sure enough, this should be 32. My apologies. See, I make mistakes all the time. It's okay though. Alright, so that's that. Moving on to part C. This time we want the sum from I equals 1 to 6. So I'm going to keep going until I hit 6. Okay? But once again, I don't have any x sub i's. I just have i's. Okay? So this is going to look like 1 minus 2 squared plus 2 minus 2 squared plus 3 minus 2 squared plus 4 minus 2 squared plus 5 minus 2 squared plus 6 minus 2 squared. And then I can stop at 6 because that's what that top index says. Okay, now order of operations. I've got to do the stuff in the parentheses first. 1 minus 2 is negative 1. 2 minus 2 is 0. 3 minus 2 is 1. 4 minus 2 is 2. 5 minus 2 is 3. And 6 minus 2 is 4. Okay, now here be very careful. If you type this into your calculator exactly the way it looks, it's going to give you a positive 1, which it should. Because negative 1 squared means negative 1 times negative 1. And a negative times a negative makes a positive. So this should be 1 plus 0 plus 1 plus 4 plus 9 plus 16. For those of you who may have forgotten how exponents work, an exponent just means multiply this thing times itself. So you're going to do 4 squared means 4 times 4, which is 16. And 3 squared means 3 times 3, which is 9. If all else fails, just use your calculator. Just at this stage, you can just type this into your calculator. But anyway, we should get what? So 25, 29, 30, 31. So we should get 31 here. Better check again in case I made a mistake. That's correct, 31. Okay, part D. So we're going to take turns plugging in for I, 1, and then 2, and then 3, and then 4. This time we're going to get x1 minus 2 squared, plus x2 minus 2 squared, plus x3 minus 2 squared, plus x4 minus 2 squared. And then we can use our data set up here to replace the x1, x2, x3, x4. x1 should be 7, right? x2 is 2, x3 is 8, and x4 is 3. So we're going to say this is 7 minus 2 squared plus 2 minus 2 squared plus 8 minus 2 squared plus 3 minus 2 squared. So that's 5 squared plus 0 squared plus 6 squared plus 1 squared. And at this point, you could go ahead and square those, 25, 0, 36, and 1, and then add those up, or you could just punch it into your calculator. So I'm going to go ahead and punch it into the calculator. I'm going to say, okay, 5, here's how you get an exponent on the Google calculator. You press this button, squared, okay, plus 0 squared plus 6 squared plus 1 squared. And you should get 62. Okay. And let me check. Yep, that's also correct. Okay. Moving on. I think this is the same data set as the previous page. The data set is 7, 2, 8, and 3. This time we're going to start doing something slightly more complicated. So we've got the sum from I equals 1 to 4 of xi divided by 4 plus xi. So I'll tell you what I'm going to do. At this point, I'm going to stop writing down x1, x2, x3, x4. I'm just going to go ahead and replace them with the values that they represent. Okay, so I know that that x1 would be the first value in the data set. That's 7. So this is going to be 7 over 4 plus 7 plus. Then I'm going to do the second value in the data set. That's 2. So it's going to be 2 over 4 plus 2. Okay, do you see what I'm doing? I'm replacing these xi's with the first value in the data set and then the second value in the data set. I'm going to do that again. This is 8 over 4 plus 8. And then the last one is a 3 over 4 plus 3. You could punch this all into your calculator at this point. I'm going to take it probably one more step before I punch it into my calculator, and I'm going to go ahead and add up those denominators. So this is going to be 7 over 11 plus 2 over 6 plus 8 over 12 plus 3 over 7. And at that point, I would just go ahead and plug it into my calculator to see what we get. So 7 over 11 plus 2 over 6 plus 8 over 12 plus 3 over 7 is about 2.06. I said to round to 3 decimal places. So 1, 2, 3. I look at the 4th decimal place, and it's bigger than 5, so I'm going to round this up to a 5. I'm going to call this 2.065. That's how I round to 3 decimal places. So 2.065. And just checking to make sure I got that right. Yep, 2.065. Okay, part F. This one's a little more complicated still. But this time, so this is actually pretty similar looking to part E, but notice that in part E, I wanted to do this expression and then add them up. Here I want to add the numerator and denominator separately and then do the division at the very end. So here's what this is going to look like. If I just focus on the numerator part, I want to add up all of the xi's. So I want to do x1 plus x2 plus x3 plus x4. Well, x1 is 7, x2 is 2, x3 is 8, and x4 is 3. So this is going to be 7 plus 2 plus 8 plus 3. And then I want to divide that by the sum of 4 plus x1 plus 4 plus x2 plus 4 plus x3 plus 4 plus x4. So this is going to look like 4 plus 7 plus 4 plus 2 plus 4 plus 8 plus 4 plus 3. And that's what the denominator is going to look like. So I'm going to punch this into my calculator. Let me just do one step real quick. 4 plus 7 is 11. 4 plus 2 is 6. 4 plus 8 is 12. And 4 plus 3 is 7. So now I'm going to go ahead and punch this into my calculator. Make sure to use parentheses in the numerator and in the denominator when you're punching this into your calculator. Let's see what we get. So I'm going to open up a set of parentheses and say 7 plus 2 plus 8 plus 3, close the parentheses, divide by, and then open up a new set of parentheses, 11 plus 6 plus 12 plus 7, close that parentheses. And rounding to 3 decimal places. Let's see, there's the third decimal place right there. I look at the decimal place after it, and it's a 5 or more, so I'm going to round the third decimal place up to a 6. And then drop the rest of the digits. So this should be about 0.556. Okay, so there's that one. And then I think I have one more on the last page. Okay, so let's take a look at it. Okay, same data set, 7, 2, 8, and 3. This is a calculation that's very, very similar to a calculation that we're going to be doing in section 3.2. So if this looks really, really complicated to you, the reason that I'm giving it to you is to prep you for what we're going to be doing in the actual statistics course. We're going to be doing calculations like this all the time. This is very similar to the standard deviation calculation. In fact, it might be the standard deviation. I don't think it actually is, because I think this number is wrong. But it's a similar type of thing. So here's how this works. We want to take the square root of this expression, the entire expression, not just of the numerator, but of the denominator as well. So I'm going to kind of ignore the square root for now and focus just on the stuff inside of the square root. Inside of the square root, I've got to add up all of the xi minus 3's squared. So first I have to do xi minus 3 for each of these data values. Then I have to square the result. Then I have to add all of those up. And then finally I'll divide by 4 minus 1. And at the very, very end, I'll take the square root. So that's kind of that's the name of the game here. So let's see what we get. Okay, so I'm going to have this large square root. I want to do x1 minus 3. Well, x1 is 7. So this is 7 minus 3 squared plus. Then I want to do x2 minus 3. x2 is 2, so this is going to be 2 minus 3 squared. And then I want to plug in x3. That's an 8. So I'm going to say plus 8 minus 3 squared. And then I want to do x4 minus 3. x4 is 3, so this is going to be 3 minus 3 squared. And then I want to divide that whole thing by 4 minus 1, and then take the square root. Okay. Now, at this point, you could go ahead and plug this into your calculator. I think I'm going to do maybe a couple more steps. So I'm going to take care of all the subtractions. I know 7 minus 3 is 4. 2 minus 3 is negative 1. 8 minus 3 is 5. And 3 minus 3 is 0. I also know that 4 minus 1 is 3. So I can just replace that in the denominator. So already that's looking a little bit nicer to me. I could punch this into my calculator now, but I think I'm going to take it one more step and then punch it in. So I want to do all of those squares now. So 4 squared, that's 4 times 4, 16. Negative 1 squared is negative 1 times negative 1, that's positive 1. 5 squared is 5 times 5, that's 25. 0 squared is 0 times 0, which is just 0. Okay, I'm going to punch this into my calculator now. Okay, so it's going to look like this. Open up a square root. It automatically opens a set of parentheses, but you need to open up another set of parentheses so that you can do the numerator of that fraction, 16 plus 1 plus 25 plus 0, and close it off. And then you want to divide by the 3. And then you close off the parentheses for around the radical. So that comes out to about 3.742 if I round to 3 decimal places. Okay, and that's that. So so there's our review of order of operations as well as our introduction to summation notation. Okay, so I'll check in with you later.